Hey there, welcome back. So this is Ramandeep Singh, and today we'll be solving this easy problem, which is binary tree in order traversal. So just to warm up, like I'll be solving a lot of problems of this topic, and this is one of the easy problems. So I'll be solving this today. This is an easy one. Binary tree in order traversals. What is a binary tree? I'm assuming all of you know about it. So let's just see how we can solve this. Given the root of a binary tree, return the in order traversal of the nodes values. So what is an in order traversal? Let's first understand that. So let's take this tree to understand the in order traversal better. 1 2 3 इसको बनाते हैं. 1 2 3, then we have 4 5 6 7. We have 4, here we have 5, here we have 6, and then we have 7. And here we have 3 8 9. Okay, let's start this. So let's see what is in order traversal. This is the root node. This is a binary tree and this is the root node. In order traversal means first we visit the left node, then we visit the root node or the middle node, and then we visit the right node. Or we can say, if let's say this is the parent, then first we visit the left child, then the parent, then the right, like this. So that's the in order. It is in order. In order means just move from left to right. Left, root, right. So we are at the root. We move to the left. Since this is a binary tree and we are traversing it in order fashion, we move to the left child here. This is also a binary tree. So we again apply the same thing for this node as well. So we again move to the left child. Now we again move to the left child. This node do not have any left child. We can see that. Do not have any left child. So the left child is null. ठीक है. So left child is null, and then we come to the root node. So what is the root node for this subtree? It's 4. So we visit it. And then we move to the right child. So what is the right child for this one? Null. ठीक है. We move back. We do not push null. We do not push null nodes. Okay. Now we move backtrack to the parent. So for this binary tree, we have visited the left subtree. Left subtree is done. Now we visit this one. So we visit 2. So we push 2. Then for this one, we move to the right side. This is the right one. This is the right subtree. Now we move here for 5. Again, same rule hold for every node. Left, root, right. So for 5, move to the left. 6. Again, same rule. For 6, move to the left. Null, nothing. Do not have left child. Now move to the root. Push it. Move to the right. Nothing. Move back. Left subtree is done. Visit this. Push this. Move to the right subtree. This 7. Do not have any left child, so visit 7. Do not have any right child. Move back here. So this tree is again done. Now move back here. 2. So for 2, we have visited its left. Then we visited 2, and then we visited the right. So let's see how the order actually looks like for this binary tree rooted at this node. The in order traversal is like this: 4 2 6 5 7. 4 2 6 5 7. ठीक है. 4 2 6 5 7. So can you, like, just given this much information, can you just pause here and try to predict the rest of the traversal with just this information? So we had a tree, like let's say we had tree 5 6 5 7 6 5 7. For 2 we had 4 2 6 5 7. Now just try to figure out for this one, root this node. This is already done. Try to figure out this one. Just let's just see how it will look like. Now from 2 we are done, so we are done visiting the left side of the binary tree rooted at this node. So this is done. Now we are at this node, so we push 1, and now we move to the right side, so we move to 3. 3 do not have any left child, nothing, so we move to 3 itself. We push 3, we move to the right one, which is 8. 8 has left subtree rooted at 9. 9 do not have any left subtree, so we push 9. Do not have any right subtree, we move back. 8, let's push it. Do not have any right subtree, done. 1 3 9 8. 4 2 6 5 7 1 3 9 8. 4 2 6 5 7 1 3 9 8. Cool है, 1 3 9 8. 1 3 9 8. ठीक है. I hope you got the idea how we traversed it. So for every node, all you have to do, so for every node, just do this. Move to its left child, then move to the node itself, then move to the right. Just keep repeating this one for every node, and you will get your get the array containing the in-order traversal. Cool hai? So let's write the function for it. So we will create a helper function, so we will be coding it. So it's there is a property which holds for every node, hai na? So let's create a recursive function. Let's call it in order, and it takes a node. Let's call it root node. It takes in the root node. Now let's say we have an answer array. We have this answer array. This array stores the in order traversal. Now if root is not none, अगर तो none है तो ठीक है, जाने दो. If it is not none, then what you have to do is, if it is not none, then what we will do is, we will first move to the left child. So just repeat the same thing, just repeat this, recursively call the same function in order for root dot left. Now this function call is going to handle the left subtree, ठीक है. Now we push the current value in the array, answer dot append root dot value. Then we again call in order for the right one. Right subtree. So in this fashion, this is going to look like in order, then answer, then in order for left subtree, then the current node, and then in order for the right subtree. So in this fashion, this thing is going to look like. Cool hai? Anything which we have left? तो it's more of like कि ठीक है, हमने in order call किया for root के लिए, है ना? इसने in turn call किया in order लेफ्ट सब ट्री के लिए. फिर वापस आए, फिर इसने कॉल किया खुद को, it itself called for root dot write and so on. It recursively expands itself until the null node is encountered, and then it backtracks. So I'm not I'm not teaching recursion here. We're just trying to solve this problem, and that's the simple solution for this problem. Let's jump to the code implementation part. So let's create a helper function. Let's call it Inorder, and it takes in the root node, and let's say the answer array. If root, इसको थोड़ा zoom कर लेते हैं. ठीक है. So if root is not none, then answer dot append root dot. Acha, if root is not none, then let's call self dot in order root dot left, and let's append root dot value, otherwise self dot in order root dot write answer, like this. Okay, and here we have this answer, and then we have this answer, and then we call in order for self dot in order for root, and then answer, return answer. Cool है. चलो आगे देखते हैं इसको. Got AC. ठीक है. So all we did is just create this an array. We called this function helper function in order, and it just worked out. So this was an easy problem, and got accepted. So what's the time complexity for this? Since we're visiting every single node, since we're visiting each node every single time, the time complexity becomes big of, and space complexity is constant, no auxiliary space, but big of an call stack, recursive call. Cool. And that's all for this video, and I hope you learned something. I hope you get better clarity about this Inorder traversal, and it's one of the basic primitive traversal of binary tree traversals. There are two more, pre-order and post-order. We'll discuss those in the next video, and that's all for this video. Bye bye, see you.